So I see there's some still DG400 owners out there. Yes. I owned a 400 for probably 15 or more years. And it was my first motor glider. And I got to be very familiar with the things that could break on it. So we'll go through it. First off, I'm not an A&P, so you got to take everything I say with a grain of salt. Get it confirmed by your own mechanic, because he or she is going to be the one that will have to sign off on it each year on your condition inspection. So this is for information purposes only, and that's that. All right, we got these 5 categories. We'll talk about airframe controls, engine, electrical, and instruments. We'll be primarily talking about the engine and some about the electrical, not much about the others. And exploring the engine more, we got these 6 categories that we take a look at: fuel ignitions, the exhaust system, extension mechanism, and engine internal parts. I used 100 low lead exclusively. I would recommend staying away from MoGas because unless you can get MoGas without ethanol, you risk doing a lot of damage to the engine, especially the rubber parts. And maybe rubber parts you don't even see, like associated with the fuel tank. And so just stick to aviation grade fuel. At some point they'll have this new, gamma lead-free aviation fuel. That's around the corner. But it's been around the corner for the last 5 or 10 years. So I'll believe it when I see it, but it will come eventually. And then there's fuel lines, and the rubber hoses used by DG had an extraordinarily short lifespan, 3 to 5 years. And they just expect you to replace them every 3 to 5 years. And, there's cars running around with fuel lines. They're 30 years old. You're not replacing those every 3 to 5 years. So I changed my fuel lines to automotive type or aviation type.
Tom?
What?
I just changed my fuel lines and got the latest ones from DG, and now they're saying 10 years on those, and those are actually labeled marine fuel lines, which makes a lot of sense for a two-stroke motor.
Oh, good. They wised up. I'm glad to hear. It's been over 10 years since I had my 400. I went to also armored lines on the top side that were by the engine. Then there's the ignition issues. The original Bosch Polar Fire modules went out of production, and DG switched to the Ducati modules, which required a new mounting plate for them. A lot of problems with these ignition modules are wire breakage due to vibration. And so you can, put that silicone over the wires to make a strain relief where they go into the modules is a big help in reducing that breakage due to vibration. And troubleshooting an ignition problem, first off, you have to figure out, if it's just a single ignition that's failing or everything's failing. If it's a single ignition, you can isolate it by swapping between the two components. They swap the spark plugs, swap the ignition lines, and swap the the ignition coils that are inside under the flywheel. I'll talk more about those ignition coils. That shows the basic schematic of the ignition circuit, where you have these coils here that generate a pulse that go to the modules that convert that low voltage pulse to a high voltage pulse that goes to the spark plugs. Of course, you can have an interruption anywhere in here. You can have a bad spark plug wire, you could have a bad plug. Of course, the first rule of troubleshooting ignition with these two-cycle engines is change the plugs. Before you do anything, just put in brand new plugs. Because if you have a bad plug, you may not be able to visually look at it and see that it's bad. It could be, you have a cracked insulator that's not visible to you, for example. So just change the doggone plugs and then start troubleshooting after that. This shows brand new coils that look pristine. And this is what they turn out to be after some years of operation. They get baked inside that housing, literally. And the 400 came out with little covers over that area on the flywheel. And DG in their instructions say, remove that cover, don't anticipate reusing it. They just leave it off to help the heat escape, because it just traps heat in there. Eventually these coils fail because they get so doggone hot that the enamel coated wire that these things are wound with just starts failing, and you start getting windings short to each other. And one of the troubleshooting tips from DG is to check the resistance of the coil. And I think they say it should be with a new one around 400 ohms. And if it gets down below 250 or 200 ohms, they say replace it. Well, you can't get them anymore. So you have to rewind them. And I've rewound a number of them for myself and for other people. And I came up with this crude but effective rewinding setup, which uses an electric drill. This is a Variac, it's a variable AC transformer that I use to control the speed. I mean, this is a variable speed drill, but it's worthless for this. I mean, you really want to have very fine control over speed. Then I made a mandrel that I could mount the coil on. And then I got this apparatus here. This is the spool of wire. I'm trying to remember if it's 38 gauge. I think it's 38, but it might be 36 gauge wire. I've got a big spool of this now. And can't see it, but in here I put a little spring to put some tension on the reel. So the reel just doesn't take off, because it'll have some inertia. And when you slow it down, all of a sudden this guy will keep spinning and you'll have wire every place. So there's a spring in there. And this is a guide. There's a threaded shaft here with this knob, and I can control the feeding of the wire onto the mandrel. So you have to go back and forth. I mean, it takes a lot of turns to rewind this. It's several thousand turns. So, and as you're doing this, or as I'm doing it, I apply epoxy to the wire. So this thing is all potted in epoxy. And after I get it wound, then I bake it in the oven at a couple hundred degrees for a couple hours to cure the epoxy. That's a close-up of the mechanism. You can that wire is so thin you can barely see it there, but there it is. And this is on a coil that hasn't been stripped down. This is for illustration purposes only. One of the things you have to do is get in there with a box cutter knife or something like that and strip all of this old covering. This is a glass tape that goes over the coil after you wind it. So that's all got to be cut off, and the coil has to be cleaned up. There's a close-up there. You can see this 2 springs I have there to control the tension. That's a close-up of the mandrel I made. It's crude. It's all handmade, but it's effective. It works. And that's the the glass cloth electrical tape. It's Scotch 69. And you also have to get this copper foil, which has conductive adhesive, because you got to wrap this around the coil form, the steel form, so you can wind the wire on it. This shows a coil that's been stripped down before and after. And DG had 2 versions. This is the second version, which has this plastic form underneath. The original did not have this. Okay, any questions about winding coils? Yes.
How do you know when you're done? How many turns?
Until you get as many on there, do this. Measure the diameter before you start, and then you wind it till you get that same diameter back. Because you can't realistically measure the resistance without breaking the wire. So it's not important to get the exact number of turns, just so you get the voltage out to trigger those ignition coils. And you can measure the resistance afterwards. You can note that. But okay, spark plugs are a notorious problem area. DG used the standard NGK plugs for many years. And I switched to the iridium plug because it was more durable, had a more consistent spark. Starting was easier with iridium, and it resists falling better. And you can tell a lot about how your engine's running by looking at the condition of the plug when you pull it out. So you can see there on the top, there's evidence that you're getting fouling from having too rich of a, well, this is really too rich here. And there you can see the plug has been eaten away. This is evidence of overheating, which is a real lean engine. And we're going through this. Since I did this, I got my Schleicher Wankel engine. To troubleshoot it, I came up with an air-fuel ratio meter. And I think I stuck a slide in here someplace on that. But I've concluded that monitoring the air-fuel ratio is probably the best method for tuning carburetors that exists. All right, we have diaphragm carburetors. How many of you ever taken the carb apart to look at it? Okay, all of you. So I don't have to explain this much. But I'll tell you one little story. One year I was flying. We have an annual meet at Parowan, Utah, and I went early to go to Heber, which is, north of Parowan, back east of Salt Lake City. And I got all rigged, got out to the end of the runway, applied full power. I did a run up, so everything sounded good. Did full power, then the engine just started gradually losing power. And I was just barely able to taxi off the runway. And as I got out and rotated the prop, it got harder and harder to rotate. Then I couldn't rotate it at all. Oh God, I got something major is broken in the engine. So at least it was vertical. I thought, well, I'll just de-rig, go to Parowan where we had tows. I'll just get tows. We don't have tows anymore, but we did then. Well, when I got there, I pulled the plugs and all this fuel drained out. You know what I'm going to talk about, I can see already. What happened was one of the carbs got some sort of contamination, grit or something, under the needle valve. And so fuel just kept rolling into the carb unabated until it hydrolocked or fuel locked on the carb. So, keeping these carbs clean is a big deal. And, when I got there, I took them apart and I took carb cleaner and sprayed, but I never found what was plugging the carb. So I'll talk about testing of carbs here. Okay, that shows what I did on my engine with the armor-plated fuel lines. This is a vent hole, and you can check, a quick check to see if you're getting fuel is to take off both air cleaners, take something pointed, like a toothpick even, you just push it into this vent hole, with the ignition on, and look down the throat of the carburetor. If you see fuel flowing, then you got fuel pressure. There's no blockage. If you don't see it, then you got a problem with fuel delivery. Okay, how many have heard of a carb pop-off tester? 1, 2, okay. This is a critical item. What this does is it tests the pop-off pressure of the needle valve. And there's a specific pressure. I don't recall what it is on a DG anymore. It's like 11.5 PSI on the ASH26E. That's the pressure. When you apply that amount, the needle valve lifts, allowing fuel to flow. Then it'll flow in, pressure will equalize, and it'll drop off. So the pop off is that initial pressure it pops off at. Then the pressure will drop to a lower pressure, and it should hold that pressure. A friend of mine was having trouble with his 26, and I kept on asking him, have you done a pop-off test? And he ignored me, and I kept pestering him. And finally, he went and did it, and it popped off at the right pressure. It went down to the correct second pressure, but then it slowly leaked down from that second pressure. He had contamination under his needle valve, which is allowing that pressure to leak off. Okay.
Tom, is that a whole vacuum? Is it the vacuum or is it pressure?
That's pressure.
Just wondering.
Yeah, it has a little pump there that you can pump up the pressure and get it to the level that that needle valve lifts, allowing fuel to flow. All right, every internal combustion engine requires oxygen and fuel to run. The ratio of these two needs to be in the right range. If you have too much fuel, you'll run rough. If you have too little fuel, it's going to run hot. And I've actually seen people that have burnt a cylinder, by leaning it out too much. And it gets so hot that it burns a hole in the cylinder. So this needs to be in the correct range to run. And I early on put in a EGT, which is EGT stands for exhaust gas temperature, to help in this regard. But I didn't use this on the 400, but I did on my ASH26. And this is an air-fuel ratio meter. Now, all modern cars are fuel injected, and all of them have oxygen sensors. This is the oxygen sensor right here. And they measure the air-fuel ratio directly with this meter. There's a digital readout when it's running that shows you just exactly what the ratio is. Ideally, if you're getting complete combustion, it's like 14.7. But we want it lower than that. We want it richer, like around 12.5 at full wide open throttle. And so I built this. This is a sniffer that sits on behind the engine, and these are just standard hardware, iron hardware pipes from the hardware store. And this is a T fitting right here. And I can't get them with threads to fit the oxygen sensor, so I reamed out this part of the T so I could get the sensor in there. Then I used JB weld. A similar thing could be made for the 400. Just a little bit different kind of piping to sniff the exhaust, from the muffler. But here's the EGT probes mounted, on the exhaust. I had these welded in place. I used this MGL engine monitor. Okay, moving on. Here's another problem that the 400s suffer from. The muffler's held on by 3 springs. And these springs have a bad habit of breaking because of the vibration. They just continually are working back and forth. This work hardens them and for causing ultimately the spring to break. Well, you can solve this by putting some high temperature RTV on the spring, which dampens out that vibration. Real simple fix. And I've had to replace my starter motor several times on the 400. How many have had to replace their starter motor? Okay.
I was able to find an old school armature place in town, and they rewound it for me in about an hour and a half.
Oh, wow.
They were able to fix it for $40, but
That's a cheap
they
fix.
have unfortunately closed now.
Oh, I couldn't find a place to rewind it. I got a different one, a Bosch, but the dimensions on it are.
They rewound it, they just replaced the brushes.
Oh,
They were able to just do the brushes as a Bosch core, and in little to no time they had me going.
but I had to modify this mounting block here. That's a horror story I'll talk about because this starter motor has a thicker flange, so it sticks this gear out farther. This shows the original starter motor and the one that I could find in the US. Having good batteries is critical for any motor glider. And I do a test on the batteries, which is a internal resistance test. All batteries have internal resistance, and to get that starter turning, it requires up to 140 amps. Once it's turning, that current drops down to 80 to 100 amps. But if the battery can't deliver that 140 amps, it's just going to sit stalled. It won't turn. Once it starts turning, it generates what's called back EMF, a back voltage, which reduces the current requirement. The motor acts as a generator. And so you can test the internal resistance of the battery with this setup here. This is a battery load tester from Harbor Freight. It has a voltmeter on there, and it switches in about roughly 100 amp load. I measured it here this last week, and it was actually like 84 amps. And then I've got a clamp-on DC ammeter. And if you don't have a clamp-on DC ammeter, buy one, because they're really handy devices for troubleshooting DC systems. They'll show you, they just clamp around the wire, and they show you the DC current. And then a voltmeter. And internal resistance, what you do is you monitor the voltage before you apply the load, then you monitor it after you apply the load, so you get a voltage drop. And that voltage drop divided by the current is the internal battery resistance. On a new battery combination like this, it should be in the neighborhood of 10 milliohms, 10 thousandths of an ohm. And if it starts creeping up on you, I mean, if it gets to 20, time to replace the battery because it doesn't have much life left. The internal parts of the battery start failing is what's going on. They don't act as a battery anymore. And so what's left has to, do the job. You can also check the health of the battery by doing a discharge test. And there's battery discharge devices. I got a computer-based battery analyzer that will do it for me. And my battery charger that I got from High Tech, it's called High Tech RCDX1 or something like that, multi-charger. It'll use either DC input or AC input. The extension drive has been known to fail. I had an issue once where it wouldn't run. I thought it was the electric brake, and I found a new one from Germany that another glider pilot got for me, and I put it on, and that solved the problem. And then I found that the original one was still working because I had to take it out of the glider to do this. And there wasn't anything wrong with this electric brake. But, I think it's normally in the brake condition, and then when you energize it, it goes to no brake. So I don't know if what happened to it, but anyhow, that's been an issue. Has anybody else had problems with this extension? What was your problem?
I'm not sure what was wrong with it. I ordered the new one and put it on, and I'm glad it did because it went from the 13 seconds to about 7.
7 seconds?
Much more robust.
Wow.
I think they've upgraded the mechanism.
They must have. What'd they charge you for that?
Too much. Slept since then. I try not to
Think about
just
it.
think about how many toes you get.
It's a bad memory.
For maintenance fee,
I was just curious. I once had an incident which required replacing this extension mechanism. I think it was a couple $1,000, maybe more. And this was many years ago.
I don't think it was that bad, but I have somebody that works with me at the airport and lets me do a
Well,
lot of wrench turning and looks at it and blesses it.
well, Oliver Dyer Bennett did the repair, and he takes any part that he gets from DG, or he did, and doubles or triples the price. And I got billed to the insurance company because it was an insured loss. Okay, here's an issue which is not well known. This is the one of 4 bolts that secures the mast to the motor, the engine. And there's 2 in the rear and 2 in the front. And they both, I forget how the front is mounted, but in the rear there's this funky mounting block, which has an angled face to it and a hole that is too big for the bolt. It has a breakout to it. I don't know if I have a better photograph of that. I mean, this is the fix. No, I guess this is it. But I had these bolts break. If you've ever taken this off, and there's an AD where you have to take it off to inspect it, there's a big hole, which is too big for the bolt, and then there's a spacer that goes into that hole, and the hole breaks out on one side, on the inside of this mounting block. And this creates a stress riser in the block, which it's a stress crack initiator point, because you have sharp points coming together. And that concentrates stress and is just, almost guaranteed to crack at that point. So, after I had mine, and it was a mess, because when these first one bolt broke, and then I felt the vibration noticeably increase. And so I'm thinking, what's going wrong? And it wasn't but a few seconds after that the second one, which was now taking all of the load, it was only taking half of the load before it got all of the load, it broke too. And with those two broken, that whole mast pivoted forward and the prop tore in to the propeller pulley and the fuel lines, and it was a mess. And of course, it was horrible vibration in the cockpit. And I immediately shut the engine down. And I tried to stop the prop so I could retract it. Well, the prop brake didn't work anymore. I thought, what the hell? So I just retracted the prop part way down. I was quite a ways away from the airport at that point. I thought, I don't know if I'm going to make it. It turned out I didn't have any problem making it back to the airport. When I got out, I realized I didn't have any problem. Well, the propeller was totally gone. So, that dive brake, that the propeller is when the engine is not running, wasn't there. So I didn't have as much, drag as I would have normally. And, a friend of mine that has a 400, he took this apart and inspected these mounting blocks. And what he found, one of them had a circumferential crack that went 90% around the block. And you could not see it from, as assembled. You had to take it apart to inspect it. And, a AD went out 2002, maybe, I don't know, a year after I had my incident, that required inspection of this. Well, what we did was we had custom blocks machined that got away with that spacer and that cutout hole. Now it's just a normal hole. And, DG designed this funky bolt. Has any of you ever taken this bolt out to inspect it? Or you should, because the AD requires this. And the bolt necks down in the center and then widens back out again. And they did that to turn the thing into a spring. And this is supposed to keep torque on the bolt. So when you torque it, because these are all dissimilar metals, this is steel, this mounting block and the engine are aluminum. You got two different coefficients of expansion, and so as it heats up, what you think you have torque-wise on this bolt changes. And it could get so bad you don't have any torque whatsoever on that bolt. Then it's free to loosen up on you. This is a well-known issue, especially in the electrical industry where they're dealing with dissimilar metals like copper and steel. And you can get a spring. These are Belleville washers. They're a washer that's a spring. They're cone shaped. They look like that. You can see here, this is a curved surface there. And as you flatten it down, it acts as a spring. And you can stack them up to get more or less spring force. So I came up with what I thought the right torque should be and I had to order 100 of these things. I only needed like 4. And to make them fit, I had to grind them down on 2 sides. But I put those in with the new mounting blocks. And after I did that, I had no more problems. In fact, after that incident, I had it happen to me a second time at Parowan. And I was climbing out, and I felt the vibration increase. I said, "Uh-oh," and immediately shut off the engine. And I was up high enough, I could just thermal away. Well, after flying out, and I figured I did not have the engine. I was a pure glider, like that, a ballasted pure glider. I could not run the engine again. When I got back on the ground, one of those 2 bolts had broken. And I would have had the same failure if I hadn't shut that engine down right away. So the moral of the story is if you feel vibration increase all of a sudden, shut her down. Something's wrong. It's not going to get any better. It's not going to fix itself. Shut it down, land, and troubleshoot what's going on. But there's all sorts of information out there about Belleville springs, and I've seen articles that talk about at length, about applications of them. Okay, that concludes my talk.